All right, we're going to find the relative extrema for number 25. We're going to use the second derivative test if we can. All right, so first off, though, I'm going to bring that x squared in because I don't want to have to use the product rule. So this becomes 6x squared minus x to the third. All right, so I'm going to take my first derivative. Take my first derivative, I get 12x minus 3x squared. Okay. Now I'm going to take my second derivative. My second derivative is 12 minus 6x. Okay, so I'm going to be able to use the second derivative test here. So let's find our critical numbers. 0 equals 12x minus 3x squared, taking my first derivative and setting equal to 0. I take out a 3x, I get 4 minus x. I get my first critical value to be 0, and my second critical value to be 4. All right, so now second derivative test, no need to set up any intervals. You're going to directly plug in your critical values. I'm going to plug in 0 first. When I plug in 0, I get a negative number. I'm sorry, a positive number. I get positive 12. Because I get a positive answer, that means, it sounds weird, but you have a relative minimum. All right, now I'm going to plug in 4. When I plug in 4, I get a negative answer. Because I get a negative answer, I have a relative maximum. All right, so now to get those values, I'm going to plug back into the original function. I'm using 0 and 4. Okay, so the original function with 0, I'm going to use the one that has the x squared distributed in. I get 0. So 0, comma 0 is my relative minimum. All right, now I'm going to plug in 4 into the original function. And when I plug in 4, I get 6 times 16 minus 4 to the third. So 16 times 4, 64. And then 16 times 6, 96. So I have 96 minus 64, which gets me 32. So my relative maximum is 4, 32. My relative max.